For today's lesson, we are going to do the Kangaroo Math Competition 2012 for students in year 9 and 10. In the process, we will cover how to prove that the tangent is perpendicular to the radius at the point of contact, and also discuss Euclid's proof. The number of primes is infinite. Question 11. If Adam stands on the table and Mike stands on the floor, then Adam is 80 cm taller than Mike. If Mike stands on the table and Adam is on the floor, then Mike is 1 meter taller than Adam. How high is the table? Let's draw a diagram, easier to form equation. So first, A is Adam, then on the table, and Mike on the floor, and is 80 cm taller. Adam is 80 cm taller. A, M, and H are the height of Adam, Mike, and the table. Then we have a second diagram. When Mike stands on the table, the difference is 100 cm. Okay. So now, from the first diagram, A plus H, Adam plus table, is equal to M plus 10, Mike plus 80, not 10, 80. Second diagram, Mike plus height of table equals to Adam plus 100 cm. So we have Mike, Adam, and table. 3 unknown, 2 equation only. How? Sometimes like that, we still have a chance to solve, if we observe the equation carefully. Okay. Yeah, put it up. So you notice here got A and M, here also got M and A. So it's better to add the equation. Add the equation. A plus M plus 2H. Then we have A plus M plus 80 plus 100. So A plus M cancel off. 2H is 180, height of table is 90. Okay. If you try to find A and H, it's not possible. Okay, but the height of table can be calculated. Next question. Question 12. Dennis and Mary were tossing a coin. If the coin shows head, the winner was Mary, and Dennis had to give her 2 candies. If the coin shows tails, winner was Dennis, and Mary had to give him 3 candies. After 30 games, each of them has as many candies as at the start of the game. Okay. Didn't win, didn't lose. Have the same number of candy as at the start. How many times did Dennis win? So we tabulate. If head, Dennis give Mary 2 candy. Then if tail, Mary gives Dennis 3 candies. So let there be n times head, and then therefore 30 minus n times tail, because 30 games, 30 tosses of the coin. Dennis start with X candy, and Mary start with Y candy. So now Danny gives 2 N candies because N times head. N times head. Dennis had to give 2. Then 30 minus N times tail, so we receive 3 times 30 minus N. And then Mary, the other way around, have give 3 times 30 minus N and receive 2N. So if at the start is 30 and then give away 2N and receive 3 times 30 minus N, X minus 2N and receive 3 times 30 minus N and got the same amount as at the start. For Mary, the other way around, receive 2N, give away 3 times 30 minus N, and the amount is still the same. Anyway, the 2 equations actually give us only 1 equation. That is 3 times 30 minus N minus 2N is 0. So 5N is equal to 90. N is 18. N is 18 is the number of times head. 18 times M is winner. Head, Mary winner. You want how many times Dennis win? 12 times tail. So Danny winner 12 times. Answer. Dennis won 12 times. This is all algebraic equation. Number 3. Number 3. A rectangle has length 6 cm encloses an equilateral triangle on touching the circle as shown. Okay. So what is the shortest distance between the 2 gray circles? We show a bigger picture. Then we show the measurement. Here is radius. So radius. So the whole length, radius of 6 radius. 6 radii equal to 6. Radius is 1. Then when we draw the triangle, this is 1 radius, here diameter, here radius, so 4r, here 2r. Then 60 degrees on 60 degrees. So we don't have to worry whether this is 6 or not. You say rectangle, don't need to know this one. Like that, this triangle already correct. So we want to find the distance from the center of the gray circle to the center at the bottom to help us find the shortest distance between the 2 gray circles. Find this S here from the bottom of the top gray circle to the top of the bottom gray circle. Shortest distance between the 2 gray circles. So first thing, like I have mentioned, 3 circles, diameter total add up 3 times 2r, 6r equal to 6r equal to 1. Then by Pythagoras theorem, this distance d is 16r square is 4r square. 2r all square is 4r square, 12r square. D square is 12r, r equal to 1. D square is 12. D square is 12, then d s is d minus 2r. 2r. So 12 is square root 12 is 2 root 3. 2 root 3 minus 2. This is the segment there. Geometry, geometry question. This is next question. In Billy's room, there are 4 clocks. Each clock is either slow or fast. The first clock is wrong by 2 minutes. Don't know fast or slow. Second, also wrong by 3 minutes. Third, wrong by 4 minutes. Fourth, wrong by 5 minutes. One day, Billy wanted to know the exact time by looking at his clock, which reads 6 minutes to 3. One clock reads 6 minutes to 3. The other 3 minutes to 2. 3 minutes to 3, 3 o'clock, 3 minutes, 3 o'clock. 2 minutes plus 3, plus 3 o'clock. 3 minutes plus 3 o'clock. What was the exact time? Quite an interesting question. How to do it? The exact time they give the answer, all these 5 choices. So let's tabulate. Possible exact time. One of them is a possible exact time. Then we write down the display in the other 4 clocks. First clock wrong by 2, second clock by 3, third clock by 4, fifth clock by 5, fourth clock, not fifth clock, fourth clock. So we show the display. Clock display will be based on this. So if the clock, we don't know which one is first, second, third, fourth, so we call it PQRS. When the display is one of the clock, right, 6 minutes to 3. One of the clock. 6 minutes to 3 means 2:54. Then 3 minutes to 3 means 2:57. And then 2 minutes past 3, 3:02. Then 3 minutes past 3, 3:03. These are the reading of the 4 clocks. We don't know which one is first, second, third, fourth. We don't know, but they are all wrong by this amount. Then, so we have to check whether they are wrong by this amount or not. Based on the display, based on the display read by Billy. Billy read the clock. These are the times. So if we check against the time, possible exact time, then he found that this one out by 6 minutes. If the exact time is 57, is out by 3 minutes, like that. If 58, then it is out by 4 minutes. Okay, 58 4 minutes. Then 59 is 5 minutes, and 7 minutes. Okay, so from the first reading only, we can know a little bit already. What is the exact time? The no clock is out by 6 minutes. No clock. So it cannot be clock. Clock P cannot be the answer really. 345 possible lah. No clock out by 7 minutes. But let's continue to tabulate. If this clock, if the exact time is 3 o'clock, then 3 minutes. If exact time is 2:57, then 0 minute. Then 1 minute, then 2 minutes, then 4 minutes. Okay. Then 2 minutes, 57 means 5 minutes, then 4 minutes, then 3 minutes, and 1 minute. And then 3, 6, 5, 4, 2 against the possible exact time. Then we want to see that the 4 clocks are wrong by this 4 amount. Okay. The 4 clock, if the time is 3 o'clock, it is wrong by 6, 3, 2, 3. Not the same amount. The 4 clock must be wrong by 2, 3, 4, or 5 minutes. That's given in the question, first, second, third, fourth clock. So we see that only this row, 5, 2, 3, 4, the 4 clock will be wrong by 2 minutes, 3 minutes, 4 minutes, and 5 minutes. The others got 7 and 6, got 0, 1, all out already. One also out, no 1. So only the exact time must be 2:59. So the 4 clock will be wrong by 5, 2, 3, 4. See? So P is actually the clock number 4, fourth clock, like that. The Q is the first clock. Then R is the second clock. S is the third clock. So it's a question of knowing how to organize the information. We sense you not here. Okay, next question. Diagram shows a right angle triangle with sides 5, 12, 13. What is the radius of the inscribed semicircle? So I draw a very big diagram, which is actually not necessary. Let's label. So we have to use this line added to form another right angle triangle, which is the yellow triangle. And claiming that the radius is perpendicular to the tangent. This one we accept in school. We accept. Not many books or teacher will show the proof on it. The tangent is perpendicular to the radius. We'll do the question first and look at the proof afterward. So the radius R, and then the balance 12 minus R. So there's no need to use Pythagoras theorem. We use sine theta. Sine theta is opposite over hypotenuse. So for the original triangle. For the yellow triangle, opposite is R, hypotenuse is 12 minus R. So we form the equation. Sine theta 5/13 is also R/12 minus R. We do the calculation, cross multiply, we get 60 minus 5R go to 13R, 60 is 18R, R is 10/3. Answer 10/3. Let's look at the proof. that the tangent is perpendicular to the radius at the point of contact. How to prove such a thing? Huh? First, we must be very sure what is a tangent. Definition: a tangent is a line that touches the circle at only one point. Okay, that's the definition. If a line touches the circle at only one point, then we say it's a tangent. So to prove, we suppose the tangent is not perpendicular to the radius. Okay, if it is not perpendicular to the radius, then let's look at a diagram like this. Suppose it is perpendicular, then it will be more like this. Perpendicular, and then if suppose a tangent is not perpendicular, then one angle become acute, one become obtuse. Otherwise, perpendicular is 90, 90. If not perpendicular, then become like that. Become, if acute, then you can draw isosceles triangle because radius equal. You can draw a cube. So the angle alpha here. Okay. So because it is not perpendicular, it must meet the circle at another point. Okay. If beta is acute, then you will meet on this side. This contradicts the fact that tangent touches the circle at only one point. Our line is a tangent. We suppose not perpendicular, then it touches the circle at another point. So contradict the fact that it's only one point. Hence, when the line that meets a circle is not perpendicular to the radius at the point of contact, it cannot be a tangent because it has to cut the circle at another point. Therefore, when the line is a tangent, it is perpendicular to the radius. To make it short and sweet, easier to do the reasoning, we say like that. You use the contra-positive statement. If P, then Q. If not Q, then not P. Example, if you are over 18 years old, you can vote. If you cannot vote, then you are not over 18 years old. Like that, contra-positive. If tangent, perpendicular. If not perpendicular, then not a tangent. That's what we are doing. You say not perpendicular, is not tangent. Therefore, when tangent have to be perpendicular. Okay, now we go and talk about Euclid's proof. The number of prime is infinite. How to prove? Euclid also used this method of contradiction. You cannot prove direct, so you prove indirect proof. Suppose the number of prime is not infinite. Then finite means there is a list of prime. Let all the prime, the list of all the prime be P1 up to Pn, finite. Can list all of them. Then we form a new number, n, equal to the product of all the prime plus 1. Then there are two possibilities. This new number is either a prime or a composite. There are two possibilities. N is a prime or n is composite? A composite is a product of prime. When you have like 12, 2 times 2 times 3, like that, can be expressed as a product of prime. So it's called a composite. None of the prime factors of n are in the list. How to understand? If n is a prime, it is not in the list. It is not in the list. If n is composite, all the primes are not factor because got +1. So none of the prime factors of n are in the list. Second condition, if it's composite, P1, P2 until Pn all are not factors because the number n got +1. So in both cases, if n is prime, we have a new prime. If n is composite, we cannot find a prime factor that is in our list. So that means there is also a new prime. One of the factors is a new prime. Both cases imply there exists a new prime. But you already say all already. You say finite already. So this contradict that we have already listed all the prime. Hence, the supposition that the number of prime is finite is wrong. If finite is wrong, then number of prime must be infinite. Finite is wrong, then infinite is correct. So that's Euclid's proof, thousands of years ago already. He already developed this method of contradiction. A lot of difficult results are proved by contradiction. Number 6. How many 4-digit integers are there for which the 100th digit is 3 and the sum of the other 3 is also 3? So we show a number A, B, C. The 100th digit is 3. The sum of the other 3 digits is also 3. A plus B plus C is 3. Now, looking at the answer, not many this type of integer, 4-digit integer. But how to begin? Since integer and digits, A plus B plus 3 is very restricted. They either 0, 1, 2, or 3. Then A is the first digit, so we say A is not 0 straight away. So A equal to 1. When A equal to 1, we have 3 cases. A1, 1 plus 1 plus 1, or 1 plus 2 plus 0, or 1, 0, 2. When A is 2, 2, 0, 1, or 2, 1, 0, 2 cases. When A3, only 3, 0, 0. So only 6 such number. Okay. You must say the first digit cannot be 0 first. Is 1, 2, 3. Let's see this equation, not here. Next question. Kanga is writing 12 numbers chosen from 1 to 9 in the cell 4 by 3, the grid, so that the sum of every row is the same and the sum of every column is the same. Only row among themselves the same and column among themselves the same. Row and column not necessarily the same. Kanga has already written some of the numbers as shown. What number could be written in the shaded square? Let's draw a diagram to put in our unknowns. There are 5 blanks, so let them be A, B, C, D, E. Then we look at all the rows. There are 3 rows, so we can have the same sum. Rows have the same sum. So first row 2, 4, C 2, then A 3, 3D, and then 6B 1E first row. So this actually 2 equation only, because this 8 plus C is equal to A plus D plus 6. 8 plus C also equal to 7 plus B plus D. So A plus D plus 6 is a consequence. Therefore, it's not a new equation. You cannot form 3 equations. They are imply they are already equal. A plus D plus C already equals 7 plus B plus C, because both are equal to 8 plus C. So 2 equations. We have 5 unknowns. So we form for the column. Columns have the same sum. So the 4 columns, 2A6, 4, 3B, C, 3, 1, and 2DE. Again, this is all equal to 8 plus A. So 3 equations only. All the other 3 expressions are all equal to 8 plus A. But 5 unknowns, 5 equations can solve. Can solve, but this question, what is the strategy? What kind of method? I think, use the method called the anchor variable. You can simply try here and there, substitute, eliminate, but you may get lost in the process, because 5 equation, quite a lot of manipulation. So you express everything in terms of one unknown. I call it anchor variable. This is my own term only. So we see which one to choose. We got A, B, C, D, E. Which one to choose? Then we see A 4 times. The one that appear more often must be a good choice to be the anchor variable. So let's see. You got 5 equations, 5 unknown. So we always try to use the method find all unknown in terms of one particular unknown. In terms of A, in this case, I'm going to choose A. So from here, 8 plus B is equal to A plus 1. Equation 3, equation 3, this one. So you want B in terms of A. Then equation 4, C in terms of A. Okay. So then the next one, we look for A some more. Here, D plus E from equation 1. I use this one. D plus E, A plus D is C plus 2. C plus 2. Because we got A there. Then I know C got A, so I choose the C. I don't mind. I can change to A plus 4. Then by chance, A and A cancel. D go to 6. Sometimes luckier, you find D already. Then D plus E, then you use the last one. D plus E, if you use this first, you will get E equal to A. This one is D. This one is D. D and D will cancel also. If you choose this one, D and D will cancel. So once E go to A, easy already. 8 plus C, 7 plus B plus A. Yeah. Sub into equation 2. Yeah. Sub into equation 2. Equation 2 is this one, 8 plus C. 7 plus B plus E, you change to A. Everything we try to have A. Try to have A. Then B is A plus 1. See why it's so strategic? When it's all A, that means can solve. See? So 12 is 8 plus A is 4, therefore E is 4. So anchor variable method, is a kind of substitution also. 3 athletes, Kang, Ga, and Ru, took part in a marathon race. Before the race, 4 spectators discussed the athlete chances. 4 of them talking about who can win, who can lose, discuss the chances. The first one say either Kang or Ga will win. The second say if Ga is second, Ru will win. Third say if Ga is third, then Kang cannot win, will not win. Fourth say either Ga or Ru will be second. They all talk only. After the race, it turned out all 4 statements are true. All 4 of them, what they predict is correct. Kang, Ga, and Ru were the top 3 athletes in the race. In what order did they finish? So there are 5 choices. You must check one by one and see that every 4 of them say the correct statement. So it's very confusing. So much information. So first, they learn one important reasoning. When we say a false premise, something which is false cannot be true one. Like infinity is not a number. So you say, if infinity is a number, it's a false premise, something that is not true. Then you can claim anything. Then 2 equals to 1, you say. Yeah, nobody can challenge us. If infinity is a number, you wait and see. If infinity is a number, 2 equal to 1. And here is a proof. 2 equals to 1 using the false premise. If 1 over 0 is infinity, because infinity is a number, you can divide by 0. So you cross multiply, 1 equals to 0 times infinity. Then 2 times 1 equal to 2 times 0 times infinity. Because they are equal, both sides can multiply by 2, still equal. Then 2 times 1 is 2. Then we apply the associative law. A times B plus C can be the same as A times B first, then times C. So we can do 2 times 0 first, then times infinity. And 2 times 0 is 0. 0 times infinity is equal to 1. So 2 equals to 1. So this is of course not true. So this is one way to show infinity is not a number. But if you have false premise, you can get true with it. False premise, anything can be true one. Okay. Example, if the Earth has 100 moon, then we don't need electricity at night. So who can say it's not true? You don't know, the Earth don't have 100 moon. So let's see. Okay, we write out so that we can refer all the false statements made by the spectators. Then we see, and if the result is Kangaroo, then you check. First statement, either Kang or Ga will win. True lah. Kang win, either Kang or Ga will win. Second statement, if Ga is second, Ru will win. False. If Ga is second, Kang win. So how can it be true? See? You say Ru will win if Ga is second. Ru is third. So that false. So that means A is out. All four must be true. A is out. Cannot be disorder. So order B, Kang, Ru, Ga. First statement, true, because either Kang or Ga win. Kang win, okay, true. If Ga is second, Ru will win. But it never happened. Ga is not second one. So anything you say also okay. Infinity is a number, anything also true. Ru, Ga is not second. Anything you say also can. So true, 2 is true. If Ga is third, Kang will not win. But Ga is not third. Ga is third, but Kang win. So false. Ga is third. Kang will not win. False. Kang won. So this B also incorrect. So the difficult part is this one. B say, second statement say, if Ga is second, Ga is not second, then nothing to talk about already. Anything you say also can. So we say as true. Okay. Third statement. Again, either Kang or Ga will win. Rule 1, so out lah. Straight away C is out. The fourth statement. Either Kang or Ga will win. True. First statement is true. Then second statement. If Ga is second, Ru will win. Ga is not second. Whatever you say also can allow. So true. So it's true. Okay. Then third statement. If Ga is third, Kang will not win. Again, Ga is not third. Anything you say also correct. It will not win. The third statement is true because of the false premise. The false premise. Okay. Then the fourth statement. Either Ga or Ru will be second. Correct? The Ru second one. So all true. All true. D is the correct order. Ga, Ru, Kan is the order. If we look at the last one, either Kang or Ga win. True lah. Ga won. If Ga is second, Ga is not second, anything also can. So true. Then if Ga is third, Ga is not third, anything also can. True. Then the fourth one, either Ga or Ru will be second. Not true. Kang is second. So Ga or Ru not second. So false. So that's how to do this type of question. Only difficult part is the false premise. When the premise is false, you can claim anything. So we say true. Once the premise is false, then we not say the statement true already. You see, infinity number 2 equal 1, 2 equal 1 already. 2 equal 1 already. Number 9. The diagram shows a shape formed from 2 squares with side 4 and 5 cm. A triangle with area 8 and a shaded parallelogram. What is the area of the parallelogram? So we have two squares. One is 4, one is 5. And the area is 8. This question, if Form 3, you may not have learned. So you take the chance to learn the something which called the definition of trigonometry, sine, cosine, and tangent. What is sine, cosine, and tangent? The original definition uses a right angle triangle. Then sine theta is opposite over hypotenuse, like that. Cosine is adjacent over hypotenuse. Then tangent is opposite over adjacent, like this. Must have acute angle only and a right angle triangle. Then only you have this definition, which is done by the Egyptian. Egyptian invent this ratio. All these are ratio, sine, cos, tangent. They use it so that they can make calculation. By making one measurement, they don't have to make a second measurement because they record all the values, sine, cosine, tangent. They work out carefully. So then they have a table. So if they know A, then they can find H, like that, because they know theta already, like that. They tabulate out the values in advance. So they make one measurement, they can find another measurement. There's a original definition which uses a right angle triangle. The advanced definition is no triangle. No triangle use. They use coordinates, a point on a circle. The circle radius r, and x and y are the coordinates. For the angle theta, they define using the coordinates. Sine theta is y over r. Cos theta is the x coordinate over r. R is the length, radius of the circle. Then tangent is y coordinate over x coordinate. So it still fit the definition of the original triangle. But why want to change to this advanced definition? That's the question, is it not? This is a very clever invention, If you move the circle one more round, at first theta, if you move the circle and come back, then we got 360 plus theta. Also same value, also y over r, like that, sine theta. So sine theta, y over r got many values. Each one at 360. There is a cycle. Every cycle, you get the same value. So they invent the definition so that sine, cosine, tangent has the periodic cycle, can occur for many values at regular interval, periodic. This they invent so that they can apply the definition for wave, wave or vibration, something that repeat, got cycle one. So then only they can make this mobile phone, GPS can use. This very clever definition. Actually, I tested the artificial intelligence. I think ChatGPT. I asked them, give some reason why they want to change the definition from this original to advanced. Then you say quite a lot of property, what application here, application there. Then I say, isn't it the most important is to make the definition have periodic properties. Then the AI say, wow, you are very profound. That's the most important, which no textbook has, I have come across ever write like that. The periodic property is the most important property. I think got textbook, but many of the textbook at that time I was teaching, no book mentioned this one. Okay, never mind. Now we will use this advanced definition to answer our question. So we have the square, side P, and then side Q, and then we have angle theta. Then the balance here, 180 minus theta, because 90, 90, total 360, all. Then we find the area of the triangle. Before that, we notice that sine theta is y over r. Then it is also sine 180 minus theta, because when the point comes over to this side, then this is theta. But the angle from the x-axis, 180 minus theta. The distance is still r. The x coordinate is negative, but the y coordinate is still y. So y over r, same for the definition always, the angle must start from the x-axis one. So we say sine 180 minus theta is also y over r. So got two value equal one, same ratio. Cosine also will have, tangent also will have, and we will not do that. We just use the fact that definition that I just learned shows two angles have the same ratio. Sine 30 is sine 150, same value like that. Sine 45, sine 135, same value. So if we calculate area, triangle half PQ sine theta is 8. So PQ sine theta is 16. For our parallelogram, we have two triangle. Okay. One triangle is PQ sine theta times half. Two triangles, so I didn't put the half, double already. But sine 180 minus theta is sine theta, and PQ sine theta is 16. So without this knowledge of the advanced definition, like Form 3, I think not in the syllabus, you cannot do this question. Year 9 and 10 is Form 4 and Form 5. So at least you got chance to next time be aware and ask your teacher the question, why want to change the definition? Okay, it's not to have a lot of application. That one is only a what called important partner, but not an important property. The important property is the cyclic property. You can do one more question. Okay. 2012, m power m, m power k minus k. What for positive integer m and k? What is the value of k? So we have to look at 2012 first. 2012, 2 times 1006 divided by 2 again, 2 times 503. Then we see power, 512 is the power of 2. 2 power 9 is 512. I told you, 2 power 10, you must remember 2 power 10, 1024. So 2 power 9, 512. So this match, K and K match, M and M also match. So therefore answer K equal to 9. very short question. One more question. Okay, this one. A jeweler has 12 pieces of chain, each with two links. One piece is two links. He wants to make one big necklace of them, as shown. To do this, he has to open some links and close them afterward. What is the smallest number of links he has to open? So we first make sure we understand this is one piece. One piece has two links. Each one has two links, one piece. Then, so if you got 12 pieces, I prefer to say 12 pair. 12 pieces, 24 links, because question say you got 12. Then we look at, after two links, we can open and join two more links. Two more links, yes. So they can have a second link open. So this is the first pair. You break one piece to get two open link. Two open link. Then they continue to join. Two more, and then open the second pair. Two more, and then this from the second pair, two links. And then third pair, link 5 and 6. Okay. And then two more, then link 7 and 8. 8 open to join to the front. So we have 8 links, 4 pairs, 8 links, and then in between already got two unopened one. Unopened. Open 4 pairs, get 8 open links. We number them 1 to 8. Between each link, there are 2 links not open. Not open. 2 links not open. 2 links not open. So 1, 2, 3, 4, 5, 6, 7, 8. 8 links not open. Open link plus links not open. Open 8 links. 4 pair, 4 pieces open become 8 open links. Then unopened 8 pieces or so. 8 times 2, 16. So total we have 24 links, which is 12 pieces. Smallest number of links to be opened is 8. Answer is A. Answer is A. I think the next question is too long to do already. We will stop here. Stop here, continue next week. At the back, question harder. All right, you stop here.